Hello, my name is Haoyu Wang, and here's homework 5 from class EL 6303 class, and here's the question 2. So we given here f of x and y equal to a over y squared times x, and y is greater than 1, and the x is between y and 1 over y. So first thing we need to we are asked for asked to do is draw the non-zero definition region of f(x) and y. So it's pretty straightforward. Just draw the diagram here. We can get here. So here is the, since the x is between y and 1 over y, and y is always larger than 1, so we can get the region here in the shallow part. Shallow part is the region we're looking for. So for the second question, to find a so that f(x) and y is Weyl joint density function. So to make it Weyl, we need to do is make the equation equal to 1, and in this situation we need to do the integral twice. The first thing we need to integral is dx. After we're doing this integral, we need to do another one, dy. So here is how I do it. So first do the integral inside. We can get the answer is ln x from y to 1 over y. Then we do the second, we do the integral again here to here. Then we can get the answer here. After we plug in all the numbers, we get the a times ln 1 over x minus ln y minus 2 over y from infinity to 1 times a, since we want it to be a Weyl. So this is all this equation equal to 1, and we can get here 2 times a equal to 1. A is equal to 1 over 2. So we are given f(x) of f(x) and y equal to 0.5 over y squared times x. So for the third questions, we need to find and draw the marginal density function f(x) and fy. So here's what I do. First thing we find out f of y. We do the integral from infinity to negative infinity f of x and y dx. And since we know the band rate, we know the range. We know the range, so we can get here. The range is from y to 1 over y, and 1 over x squared, y squared times x dx equal to ln y over y squared. And this is between y. This is y between infinity to 1 and equal to 0 in other case. So we draw the diagram here. It starts from 1, and it's basically in this shape. For the f(x) of x, for the f(x), we also do the same thing. We do the integral from infinity to negative infinity f of x and y dy. For x is between 0 and 1, f of x equal to integral infinity to 1 over x. Oh, I'm sorry. We do the integral. We do the integral from infinity to 1 over x, and 0.5 over y squared x times x dy, and this is equal to 0.5. And for x, if x is greater than 1, smaller than infinity, f of x equal to integral infinity to x 0.5 over y squared times x dy, and we do the integral stuff, so we can get the answer is 1 over 2x squared. Then we combine these two together. We draw a diagram here. The diagram is from 0 to 1. It is equal to 1 over 2, so it's 3 here, and for larger than 1, it goes to here. So for larger than 1, it is 1 over 2 times x squared. So we can get the diagram like this. For the first questions, we need to verify that f of x and f of y are valid density functions. So since we know we do the integral from infinity to 1 ln y over y squared, which we've already calculated from here. This is equal to 1, so f of y is a valid probability density function. For this, we get from the last questions, we get f of x is combined of these two. So we combine these two together is 0.5 plus integral from infinity to 1 over 2x squared, which answer is 1. So f of x is also a valid probability density function.